Hello, this is Lazarus at Telecom Tech, where telecom and networking technologies are simply explained. Today we'll be simply explaining MPLS labels, MPLS device roles, and the label distribution protocol. Now, whether you're new to MPLS or you just want to brush up on your understanding of the technology, this video series is just for you. You can be notified of new content within this MPLS video series by simply subscribing and enabling notifications. If you do so, you're all set. And if you find this video useful, please do click that thumbs up button. Now, in the last video, we introduced MPLS as a technology that is used to efficiently direct data between nodes. And it's a technology that you'll most often find within the core network of an ISP or other large geographically dispersed networks. Now, this here is an example of an MPLS core network connected to several customer sites. Now, the first thing we'll look at is what we call the customer edge router, or the CE router. These here are all CE routers. These are the routers at the edge of the customer network. They are equipment provided typically by the customer at their own sites, and they connect to the MPLS network. Now, behind each CE router, we have the rest of the customer network at that particular site. Now, these routers are completely oblivious to any MPLS configuration. They don't know anything about MPLS. But they, in turn, are connected to what we often call provider edge routers, or PE routers. Now, provider edge routers are those routers that exist on the edge of the MPLS infrastructure. These are the devices that connect to the customer premises equipment, which are the CE routers. So by definition, PE routers connect to one or more CE routers. Now, the term provider edge, or PE, is somewhat of an unofficial name, but it is used very often. The official name of these routers within the framework of MPLS is Label Edge Router, or LER. Now, these PEs or LERs have MPLS configuration on them. Upon ingress of a packet into the MPLS infrastructure, they are the ones that receive the packets from the CE and assign a label to them based on the configuration that has been applied for that particular customer. Similarly, upon egress of the packet from the MPLS network, the PEs are the devices that forward a packet to the correct customer after having removed the MPLS label. Now, the PE and CE devices will typically be configured as routing peers using some dynamic routing protocol. The CE router will inform the PE router of all of its own routes within the customer network using either EIGRP or OSPF or BGP or even static routing, although that's not typically recommended, but it can be done. And finally, we have what are often called the P routers, or the provider routers. These here are the P routers within the MPLS topology. These are essentially the devices that are not on the edge of the MPLS infrastructure, but they're part of the core network, interconnecting PE devices and other P routers as well. Now, like the PE device, the P designation is also somewhat unofficial, but you will see it written in this way in many MPLS diagrams and documentation. The official name of this device in the MPLS framework is Label Switch Router, or LSR. So the P routers, or the LSRs, are there to switch packets based on their labels within the MPLS core. Now, here's an overall view with all of the routers labeled in the role that they play within MPLS. Remember, CE routers are oblivious to MPLS configurations, and the CE and PE routers simply have a regular routing protocol peering between them, while PE and P routers are the only ones that have any knowledge of MPLS infrastructure and configurations. Now, let's take a look at MPLS encapsulation in a little more detail. Here we see the data going from the CE device to the PE device where a label is added. This label is added in the MPLS header, which is inserted between the layer 2 frame header and the layer 3 IP header. Remember, MPLS is often called a layer 2.5 protocol for this reason, because it fits in between these two headers. Within the MPLS header, we see various fields. For now, we'll focus on the label value, which is a 20-bit numerical value that's assigned to the particular packet. This label is what is used throughout MPLS to direct the packet to its appropriate destination. Now, if we look at the MPLS forwarding table within the PE router, we see something like this. This is the command we would use in a Cisco iOS router to see this table. Now, don't worry about the details of this output for now, just focus on this first entry here. In order to get to this destination, we are using a label of 27, and we have our destination address here. The exit interface and the next hop IP that correspond with this particular label are found here. So we know that this is the next hop we need to send our packet to. Next, when it arrives on the P router, we see this entry here. You can see that the label is being switched to label 28. The appropriate exit interface and next hop IP are also indicated here so that packet can be forwarded appropriately. On the next P router, we see this. The process continues from node to node until it gets to the final PE router that connects to the remote customer site. Now, when the P router receives something that is tagged with label 28 with a destination of 4.4.4.4, its outgoing label says pop label, which means remove the label. The label is actually removed by the last P router in the path to our intended destination. Now, once this packet reaches the PE router here, it no longer has an MPLS label, and it's just normal routing that takes place. Remember, PE and CE routers have a regular IP routing peering. So it is only IP routing that's used to get that data to its intended destination over that last link. So that's a brief, somewhat simplistic overview of this whole process of MPLS label switching and the roles that the CE, PE, and P routers play in the process. Now, these MPLS forwarding tables are entities that are much more efficient to be searched in order to determine the next hop, rather than searching through hundreds or thousands of entries within a routing table. Now, one last question that may come to mind is this: how are these labels determined, and how is the MPLS forwarding table populated? That's done using the Label Distribution Protocol, or LDP. Now, LDP is a protocol that automatically creates LDP neighbor adjacencies between all MPLS-enabled interfaces on PE and P routers. Adjacencies are created, and then neighbors can begin to exchange information about labels. Each router locally generates labels for its prefixes, and then it'll advertise those labels to its LDP neighbors. Now, that's how each MPLS router populates its MPLS forwarding table. Now, the details of this actual operation of LDP with the various control plane and forwarding plane entities that are used in this process we'll leave for another video. But for now, suffice it to say that LDP is responsible for ensuring that those forwarding tables are populated with the appropriate labels. So that's the gist of MPLS labels, device roles, and a brief introduction to the LDP protocol. So far, so good, I hope. For now, I hope you found this video useful, and if you have, please click that thumbs up button. And please subscribe to get updates to newly published videos. I'm Lazarus at Telecom Tech. I hope this has been helpful for you, and I'd like to thank you for watching.